Let's examine R and S nomenclature. Molecules that have stereocenters will have one of two configurations. Either it will be an R configuration or an S. So let's talk about how to determine which of those it is. So, first, we will need to determine the priority of each of the groups that are surrounding the stereocenter. Now, there's major considerations behind this are that a higher atomic number takes priority. And failing that being a differentiator, then a higher mass or a higher isotope mass would take a priority. And we will move out from the stereocenter until we see something that's different. And if it's not different, then it's not a stereocenter and we can stop trying to think about R and S. Now that we've determined the priority of all of our groups, what we will do is place the lowest priority group facing away from us. Generally speaking, or often, that will be a hydrogen. Hydrogen can never be the priority group because it has atomic number 1 and it's the lowest mass. So it will always be the lowest priority group if it's existing on your stereocenter. We can have stereocenters that do not have hydrogen on them, but often they do have one. And once we've done all of that, we can start to kind of number them or determine whether it's R or S. So I'm just going to kind of look down that bond that's going to face away from us. And let's say that this is the highest priority one. And then we have a 2, and then we have a 3. And then its enantiomer would be the other configuration where we have 1, 2, and then 3. Mirror image. If they count counterclockwise, so they kind of count from 1 to 2 to 3, this is known as an S configuration. Or you can think of it as a steering wheel going to the left, or turning left. S comes from sinister. That's where they got the S from. And it typically meant left. In this case, we have it moving towards the right, or clockwise. And this is the R configuration. and that was standing for rectus or right. So now that we've had the introduction to how to determine R and S, let's actually do it on some molecules. And then we'll name them as well so that we know how to properly name them. So I will draw two molecules that are enantiomers of each other. In both of these cases, this is 1-bromo, 1-chloroethane. However, one of them is the R configuration, one of them is the S. And how we denote that is by putting an R or an S in parentheses in front of the name. So I will just go ahead and write out most of the name. Like so. All right. It's one thing to look at it on a piece of paper, and I've drawn it in a way that it's relatively easy to see that bromine being the highest priority will be a number 1 right here, and then chlorine is the next highest, that's 2, and then we have a carbon over here, that's the third priority, because bromine has the highest atomic number, chlorine has the next highest, and then carbon has the next, with hydrogen in the back away from us, taking up that correct spot pointing away from us. So since this one counts around clockwise, this is an R. And we write it with the R in parentheses, and then there we go. Now, since I said that was the enantiomer, we can surmise just from that statement that this is the S configuration, but let's confirm that. You'll notice how it counts 1, 2, 3. That's going in the other direction. Right? It's going this way instead of that way. Now, I've also made some model kits of that right here. And so this is the R model kit, so I'm positioning the hydrogen so it's facing away. And then I can see highest priority, second highest, third highest. It's going in that direction, so this is the R version. I have similarly prepared the S version. So again, hydrogen facing away. And in this case, it counts from bromine to chlorine to carbon. That's moving in the left or S direction, kind of twisting counterclockwise. Okay, so those were some fairly small molecules. So let's look at something that's a little bit bigger and talk about how we determine the priority there. So this is 4-chlorooctane. And there should be a stereocenter right here at the chlorine. Now, I've made a model of this. And so let's determine the priority. So if we look here, we'll put the hydrogen facing away from us like we should. So I'll try to orient that way. And now we have the chlorine facing out, just like I've drawn on the paper here. Okay. So we have a chlorine. That's priority number 1. The next question is, what is priority number 2? Well, I move one carbon out or one bond out, and I examine, is this different from that one? Well, I have a CH2 here and I have a CH2 there. So it's not different yet. Then I will move one more out. So I will examine this carbon and that one. Are those the same? And I have a CH2 here and I have a CH2 there. So that's not different yet. Now I move out to this first carbon here. That has a CH3. And then this one, which is 3 carbons away, is a CH2. And that CH2 has another carbon on it. So, because all of the rest of these are hydrogens, that's a lower priority group. Versus here, I've got 2 hydrogens and I have a carbon bound to this carbon. That means that this entire group here is a higher priority. So this would count 1, 2, 3. This would be an R configuration because it is moving in the clockwise direction. So when you get long molecules like this, you may have to go a fair distance away from the stereocenter to determine what the priorities are. So that was an R configuration. So now that we've talked a little bit about R and S nomenclature and how to determine the priority of some basic groups, remember, higher atomic number leads to a higher priority. And if we have isotopes, we choose the one with the higher mass to be the higher priority. And we move out from the stereocenter until we find a difference. And we select the one that has the most high atomic numbers elements bound to it. And so that's why we had to go all the way out to this carbon here before we found a difference between the two. This one had a CH3. This one has 2 hydrogens and a carbon bound to it. So the carbon that's out here is increasing the priority of this entire group here. So that makes it count 1, 2, 3, with the hydrogen being 4, and we always put that facing away from us. So thank you for watching part 1 of the RS nomenclature video, and we'll see you in the next one for part 2.